Hello, good morning, everyone. Thank you for joining us today to talk about 2D hydraulic analysis quick checks with CDOT and partners. We're going to get started here shortly. We're going to have a few quick announcements, just some housekeeping stuff, and then we'll go ahead and turn it over for the presentation. And we're scheduled for an hour and a half today, but that includes some Q&A. So I think the presentation is about an hour. Is that right, Sarah and Brian?
Yes.
Okay, perfect. So a couple quick announcements. First of all, thank you to our speakers today. We have Sarah Johnson from Muller Engineering, Brian Campbell from CDOT, Kalli Wegren from CDOT, and Brian Varrella from CDOT. We are going to do some Q&A. I think there'll be some opportunities for questions and answers throughout the presentation. So please, as you have questions, go ahead and put those in the chat. We'll be paying attention to that, and we'll go ahead and try to get those questions answered. Secondly, this presentation is eligible for continuing education credits. We will go ahead and send everyone who registered for the presentation a continuing education certificate after this meeting, and that'll be 1.5 hours. I think that clears everything up in the way of housekeeping notes. So I guess you guys can go ahead and take it away. Thanks for doing this today.
All right, thank you so much, Tyler. Good morning, everyone. We're super excited that you joined us today and we can share a little bit more about our 2D Quick Check Statewide Initiative. I'm Kalli Wegren, and I'm an engineer in the Boulder residency in Region 4 in CDOT. And I have a whole team with me today. I also have Brian Campbell. He's the Region 5 hydraulic engineer. Brian Varrella, he's a resident engineer in Region 4 of the Boulder residency and the mastermind and instigator behind this whole idea and project. And also Sara Johnson, she's with Muller Engineering, and she's been our consultant lead on this project, helping us out with project management, and her team is actually putting together 2D quick checks for us. So she's been a huge asset to the team. So again, welcome, we're really excited, and we have some resources we can share out to you. Feel free to put questions in the chat. We want to make this fun and interactive, so definitely feel free to chime in whenever. And so we'll get started. So actually, we're going to start off with a poll question, get to know you guys a little bit. Which CASFM region are you representing? And Sara is helping us out with the poll question, so she'll launch that. A lot of Denver, Northeast. Awesome, I'm glad we have some people from every region. This is great. Thanks so much for doing the poll. All right, we'll start off with the why. How did this 2D quick check idea get born? So this is a project on State Highway 60 over the Little Thompson River. This 2D model was put together by Brian Varrella and Hannah Crail in 2016. And this is a CDOT project where they were replacing the existing bridge with the new 3-span bridge over the river. And you can kind of see in this picture, this is a depth grid with scaled velocity vectors. So you can kind of see this the middle span has most of the flow and high velocity. The right span also has some flow, but you can kind of see there's not too much going on in the left span over here. So this is a flow trace that was produced from the 2D model. I'm going to try and play it. So this shows the direction of flow the water is moving. And so you can see that most of the flow is going through the center span, right span, but over here on the left span, it's mostly just an eddy of spinning water. So what this model shows us is that really a two-span bridge is equally efficient. And we wouldn't know that without this 2D model analysis. So 2D software really gives you a full picture of what's going on hydraulically. And this is kind of how this idea was born, that we can utilize this technology to help us with more projects at CDOT. And next, I'm going to pass it over to Brian Campbell. He's going to do another case study real quick to show another example of how this technology can be used and benefit CDOT. So I'm going to switch screens real quick. Hang with us.
Perfect. Can you guys see this PDF?
Yes, you can see it.
So hey folks, my name is Brian Campbell. I'm Region 5, CDOT Region 5's hydraulic engineer. We're located down here in the southwest corner. Our region goes from about Montrose over to Buena Vista and then south to the New Mexico border. I'm located in Durango, and I was happy to participate with the 2D Quick Check team when Brian Varrella reached out to me and explained what the project was about. So this is a demo slash project introduction on how 2D Quick Checks can be used in your project to realize some cost savings. So this was a culvert replacement project on Red Mountain Pass in Colorado. So let's go down. Red Mountain Pass is in the southwest corner. And if we zoom in on the project site location, the two red lines are the culverts in question that were going to be replaced. The flow direction comes from the top of the screen down to the bottom of the screen. All right, so this case study was, these were two culverts that were on CDOT's essential repair list. And the essential repair list is an on-working list that we have from our staff headquarters and our asset managers that identify which culverts need to be replaced. You can see the picture on the right. This was an example of the condition that these pipes were in. So it was pretty bad. The project has started a number of years ago before I was involved, and it was designed to about a 30% level, and then it was shelved. And at that time, the proposed replacements was one 12x6 box structure and one 8x6 box structure. The design wasn't only addressing flows, but it was also addressing debris, fire concerns, and shallow cover, as well as snow melt runoff. So when we pulled this off of the shelf, one thing that we looked at was kind of just doing a project scrub, and we identified a couple places where some value engineering could be applied for some cost savings. So two major items were identifying some locations on the roadway where spill that was coming out of the channel could be mitigated, and a split flow condition that was in the basin. So it's important to point out that although our presentation is on 2D modeling and 2D quick checks, some of the things that we're going to talk about, you don't necessarily need 2D for, but it does help. It's a tool in the toolbox that we can use for our resources. But the bottom line is from looking at some of the value engineering and the outcome from the 2D modeling, that was we were able to realize some cost savings in the project to the tune of about $100,000. So let's talk about the spill on the roadway first. So when we pulled this project off of the shelf, we reviewed the hydraulic analysis, and many of you on this phone call will be familiar with High 8 and how you populate High 8 to run a hydraulic analysis of a culvert. So one important portion of the High 8 interface is the roadway spill. So if you go through HDS5, they do give you this graphic where you're looking at the roadway elevation over the culvert. And really what you're looking at is the hydraulic control. Now, whether or not that's over the culvert or somewhere else, the designer needs to review and identify. So this portion on the bottom right-hand corner is a profile through the culvert section. And at the time, the hydraulic control was identified as the center line of the roadway. But the road is on a very steep longitudinal slope. And on a steep slope, the roadside ditch may have a relief opening that is lower than that center line of roadway. And that's what we identified when we went and pulled this off the shelf and then went and looked at it in the field, was actually the hydraulic control was over on the side about 2.5 feet below what the initial assumption was. So when we looked at that, the first thing that we thought was, oh, great, now we're going to have to increase the sizes of these boxes, right? Because the hydraulic control is a little bit lower. So are we going to be able to pass the flows that we are intended to pass? Oops, sorry, clicked the wrong thing there. So when we went to the field and to bring everyone up to speed on the project team at this time, just doing a field reconnaissance, we walked up into the basin and we identified that, you know, this looks like a split flow condition could be here. The picture here on the left is me looking downstream at the channel, and this was a about summertime runoff where the channel at that location, which is the hydraulic control of the channel in that location, was almost at the bank. And these weren't anywhere near the design flows that we were looking at. So looking at it, you could see, you know, this is probably a split flow area. And we need to investigate this. Now, lucky for us, at the time that we revisited it, the state of Colorado had made significant progress on the LiDAR program. So we were able to get LiDAR in this area, and we ran a really quick model. So I'm showing you just a model, very quick run of the site location as it was before we dove into the design. And I'm going to slow it down and pause it right about here. Now, where I was standing was up in this corner looking downstream. And this is the area where the split flow condition was identified in the field as possibly existing. And after we ran a model and did some sensitivity analysis, we were able to identify that about 20% of the design flow actually spilled out of the channel and went into another catch of the basin. This is showing you that spill on the roadway, which again, you don't really need a 2D model to know that it's going to spill when you look at those elevations, but the 2D model graphic does help. So we dove into the 2D modeling, and now we know that we have this split flow condition. We started reviewing our proposed conduits at the location. Now, to address the roadway spill, we worked with our roadway design team, and the spill was happening in an area on the shoulder that we had wanted to improve anyway and make it a better parking area. So we talked about, well, if we could raise some of the elevation on the shoulder here and button it up against the hillside, we could raise that hydraulic control so it doesn't spill down the shoulder anymore. Well, that has a pretty significant design process with it to get to a final design. So in the 2D model, we just placed a weir. And this is the weir. We said we're not going to allow flow to go out of this weir, but we do want to know how deep does it get to pass the flows, and are we going to meet our headwater to depth criteria and our other velocity and capacity criteria. So in the model, we did a very quick weir to get an idea of the elevation, and then we worked with our roadway design team to button up the parking lot area, keeping in mind these depths that we needed to control for a design flow event. And then I got to open up the final layout here. I'm going to let this run through its cycle, but this was the final hydraulic model for the proposed design. I'm going to let it go through one more time, and then I'm going to pause it. You see the split flow activated right about here. And then in this location, you can see that after, again, the parking lot design wasn't in the model, but the weir was, you actually do keep the flows within the channel, and you don't spill across the roadway, and we're able to meet that design criteria. So the results from the final value engineering was that the box sizes were reduced. We were able to reduce them from a 12x6 down to an 8x6 and a 6x6. We reduced the armor associated with energy dissipation at the outlet. And then this was coupled with some minor alignment and profile changes where we were able to shorten up the structures as well. Not everything was a result of the hydraulics. Not everything was a result of the 2D modeling. So it's important to point that out. But the overall cost savings realized was about 100K. And with that, we didn't forward that to the next project. We invested more into this same project. And so we were able to address some erosion concerns that maintenance had within the project limits on Red Mountain Pass. So to sum it up, this effort, the initial effort, was really about 3 hours of design time. We had the LiDAR files, we had the software, we had our survey from the field to match things up. Pulling it all together for a quick check was about 3 hours. Now, was that final design? Absolutely not. But it was enough to get us scratching our head and to justify that we knew something was going on. This needs further investigation, and we need to dive into this. It's really important to point out that 2D analysis is not a black box. It's not a click it, run it, one and done, and you walk away. It doesn't take the place of experience and engineering judgment. It's a tool that we have in our toolbox, like all the other tools that we have to better address the questions that we are asking on our projects. So we're going to get into this in the presentation, but it is a tool that's going to help us reduce the risk with the uncertainty that comes with hydraulic modeling. So with that, I'm going to stop and hand it right back. And I think you should have it.
Awesome. Thanks, Brian. So now that you've kind of seen how we've applied 2D quick checks and how we're using them, I want to back up a little bit and kind of review the purpose and what exactly are 2D quick checks. So they're back of the envelope, quick hydraulic analysis, about 4 to 16 hours of 2D analysis. In Brian's last example, it was about 3 hours of 2D analysis, and then a couple hours of reporting or sharing out information. And we're estimating that these quick checks are about $5,000 per quick check. We put together a punch list of ideas once we do a quick check. So this includes just a summary of opportunities and any enhancements that can contribute to the project. And this process, doing a 2D quick check, is parallel to the project process. So it should have no impact to the project budget and really no impact to schedule or scope. We're only hoping to help out the scope and design in a project using these 2D quick checks. So the purpose of our 2D quick checks is to value engineer the scope of projects and reduce material costs before construction. There's our objectives there, and the three main things that we're focusing on is safety improvements, design efficiencies, and cost savings. And through these quick checks, we hope to have some of these end results. So we can value engineer before design efforts. We can discover savings and enhancements, again, before the technical work starts. We can incorporate hydraulic feedback early into the project process as not to disrupt design later on. And we really hope to modify workflow to encourage early collaboration and design iteration. Again, early on is key in getting these quick checks the most benefits. And also to encourage innovation. We want to make our projects more awesomer. So this is a typical project process at CDOT. And as I mentioned before, the highest potential for a 2D quick check is for it to be implemented at the scoping phase. So the sooner we can do a 2D quick check, the more the results can be utilized by the project team. And this leads us to our next poll question. So what two-dimensional modeling software are you familiar with? A lot of HEC-RAS. All right, mostly HEC-RAS, which is to be expected, a little bit of Flow 2D, and a little bit of SMS. This is awesome. So I just want to point out that we realize there are various 2D hydraulic modeling software available, and quick checks can be done using any of this software. But the reason CDOT is using Aquavea's SMS is because it's endorsed by the Federal Highway Administration, and we can get the software for free. There is a community version of the software that anyone can get for free, and it's available for download on Aquavea's website. So here's some of the benefits of doing a 2D quick check. So 1D, you have channel geometry that's represented by cross sections, and at each cross section, there's a hydraulic computation. Using 2D, the channel geometry is represented by thousands of elements, and hydraulic computations are done at each element. So you get a little bit more refined results, and you get a better overall picture of what's going on hydraulically. This is a table from Federal Highway Administration, and it really shows the benefits of two-dimensional modeling. So you can see in the left-hand column all the different hydraulic variables, and the one-dimensional modeling, a lot of these variables are assumed by the user or they're averaged at each cross-section. In two-dimensional modeling, these hydraulic variables are actually computed at each element. So it really, again, two-dimensional modeling really gives you a better picture of what's going on at these different project sites. And now I'm going to hand it off to Brian Varrella. He is the instigator of this idea, and he's going to talk about how these 2D quick checks have been applied and the cost savings that have led to this idea.
All right, thanks, Kalli. I'm Brian Varrella, resident engineer at the Boulder office with Colorado Department of Transportation Region 4, and apparently also the instigator of this idea. In 2016 and 2018, through those years, I was the hydraulics unit lead for Region 4, and during that time, we supported in that unit 95 individual CDOT projects. It's a lot. 95 projects in 3 years is not uncommon for specialty units across CDOT to try to manage. And when you look at that 95 project list, about half of them required a permit. Only 15% required CLOMARs. A number of them required LOMARs, but the interesting number is that last one. There are 29 of those 95 projects included a 2D model, at least one. In some cases, there were multiple 2D models applied to different places because our projects aren't always geolocated in the same space. So what we learned from this experience is between 2016 and 2018, during that 36-month period, that 1 out of 3 projects were actually benefiting from a two-dimensional hydraulic analysis quick check. Next slide, please. So when you put the numbers together, this was the breakout of that same information. Again, from 2016 to 2018, 27 different project functions, and then one more advance, please, Kalli, 54 design features. We saved a total, and this is we, CDOT, and our consulting partners, 13.6 million in that 3-year period. And I was able to move in one more project that came in from our consulting partners at the end of 2019. So by looking at this information in a 3 or 4 year period, about a $14 million savings realized in just one CDOT region, we realized we were onto something. And I want to draw your eye to that lower right corner. Most folks, when they think of applying a two-dimensional hydraulic analysis, their mind immediately goes to a hydraulic structure, usually a bridge or a culvert, particularly bridges. But you can see from that breakout of information in that lower right-hand corner in that pie chart, that wasn't always the case. We use this for revetment design, for bridge and culvert design, roadway protection, and a myriad of other things, including a couple of traffic safety projects. So we're finding utility for this tool in places we never thought we might discover it otherwise, which is part of the reason we're trying to share this out. Folks think, well, transportation, this is a long linear corridor, we're going to do everything old school. What we're finding is the new school is showing us, as Brian Campbell said earlier, that the tools in the toolbox have application elsewhere. Next slide, please. And I think looks like Sara and Brian Campbell, we're back to you all.
Sounds good. Thanks, Brian. Just to talk a little bit about the statewide initiative. There's 50 projects slated for the first year to be accomplished. CDOT has partnered with 6 firms to perform the 50 2D analyses across the state. And the partner firms are AECOM, Ayers, Jacobs, Muller, Respec, and RSNH. In partnering with these 6 firms under an NPS contract arrangement, CDOT has been able to expand the statewide expertise and cover more ground for this initiative within the performance time. And so in addition to the partner firms, there are 3 teams providing guidance, input, and direction for the initiative. And the first one of those, Team 1, is the Executive Oversight Committee. And this committee meets quarterly, and it's comprised of Chief Engineer Stephen Harrelson, who's supportive of the vision behind the 2D Quick Checks initiative, and RTD Heather Paddock in Region 4, who helped formulate the idea of the 2D Quick Check. The committee is also comprised of State Hydraulic Engineer Al Gross, State Bridge Engineer Mike Collins, asset managers, and is supported by Laura Gerard and Scott Hogan from the FHWA Resource Center. So moving on to Team 2 is the Technical Advisory Committee. They also meet quarterly, and it's comprised of a larger reach of technical practitioners, region hydraulic engineers from CDOT, private sector partners, and is also supported by the FHWA Resource Center. So now I'll turn it over to Brian Campbell to talk about Team 3.
Yeah, thanks, Sarah. So Team 3, the CDOT team, in reference to the Quick Checks project, we had a number of different roles. So of those 50 projects, 50-ish, we're going to have a breakdown of that in a slide coming up, but the CDOT team took on about 17 of those projects. We also had a role in just providing support and collaborative investigating into some of the challenges that came from the overall team when they came up in the projects that they were modeling. Part of the Team 3 activity also was to begin training and developing in-house resources and training staff to feel comfortable with pulling together the quick checks and understanding what the quick checks are. In Region 5 in particular, we're working with 2 of our other staff, and we've started from a basic level right out of the NHI 2D modeling course to the point that our staff can now go out and get the LiDAR data, can set up these models and run an initial investigation relatively quickly and start answering some of these questions, some similar to the case study that I presented before and some much larger. So the Team 3, we've been learning a lot with that process.
Awesome. So this is a map of Colorado. The purple lines represent each of the CDOT regions. And the 2D Quick Check Statewide Initiative, we've teamed together and come up with 53 projects that we're moving forward with a 2D Quick Check. So you can see in the map all these little dots here. Each of those represent a 2D Quick Check. And each of those projects were vetted to see if they would be eligible to do a 2D Quick Check. And then they were divided between our 6 consultants and in-house staff. So we've ID'd 84 projects, and we have 53 on the to-do list. 9 are in progress, 6 are nearly complete, and we have 7 complete already. And we're really excited about the results that we've seen so far, and we'll get into that a little bit more later. I also want to show you right now, so we put together a project inventory spreadsheet. So all the 84 projects that we ID'd all the information for those projects are laid out in this spreadsheet. And we have a ton of information here. As Brian Campbell alluded to earlier, we need a couple different things to make a quick check possible, and that is LiDAR, as-built, and hydrology. And so that's how we were able to vet through these projects and see if they were eligible to do a 2D quick check for. If these projects had all 3 pieces of information and it was a good fit, we were able to move forward with the project and either assign it to a consultant or start the project in-house. So a lot of work has been put into this spreadsheet, and it's really exciting to see our results starting to fill out here. So our typical workflow for this initiative is to first identify the project or asset. Next, to get background information, so get the topography, the hydrology, and the as-builts. Topo, we mostly use LIDAR from the Colorado Water Conservation Board, or survey if we have it. Next, we create a 2D analysis. This should be around 2 to 3 days. Next, we summarize the initial findings. We actually created a memo template to help streamline the process. And I want to give credit to RSNH for helping us put that memo together, because it's really made this process really efficient. And then lastly, Brian Varrella and myself are going to prepare a roll-up of summary of recommendations that we can present out to the EOC and TAC. And once this is all done and we've completed our 53 projects, we can share this out with Federal Highways Administration and other DOTs. So now to the fun stuff, our actual results and work products and deliverables. So we've gotten quite a few deliverables throughout this process. We've started a summary matrix to keep track of all the different recommendations we've received. We're also tracking costs and hours. Like I mentioned in the beginning, we're estimating about 40 hours per quick check at $5,000. So we're just tracking that through these 53 projects to make sure that that's in the right ballpark. We're also capturing best practices. So what's something really unique is we're working together with our 6 consultants, and we're all sharing tips and tricks and ideas. And so we're trying to capture those to share out to everyone. We also have 1-page success stories that we can share out externally. And something really exciting that was kind of born from this idea was putting together a GIS library for CDOT. So we can actually, it's an interactive way for others at CDOT to look at different roadway features and see what information is ready available. So they can quickly look at a project location and see if there's H&H available, as-built, LIDAR. This library is definitely in the beginning stages. It's in the works now with CDOT and with help with Muller Engineering. But stay tuned. Hopefully we have more on that. So I can show you some of these deliverables now. So this is the project inventory spreadsheet that I just showed you. And in our other tab, we have copied all these projects over, and this is where we are recording our different recommendations. So this first part here, let me zoom in, see if that helps. So the first section here is all the different innovations that we've captured. It's just a summary. And then we've actually listed out the recommendations here at the end. So you can see we've gotten a wide range of different recommendations, either replacing structures, safety recommendations, breakout roadway flow. We also realize on some projects that 1D analysis might be better with regulatory agents and regulatory processes. So that's something that our consultants have been recommending as well. We can go back over here so we can see we have 4 new structure recommendations, 3 modified site plan and right-of-way, off-highway improvements, protecting the roadway prism. So this is a great way that we're able to track all the different recommendations, and hopefully we kind of start seeing some more trends as more of these projects start getting turned in. I also mentioned our best practices spreadsheet. So all our consultants have access to this, and we're able to they're able to edit, and if they find any best practice, standard practice, or innovation they think is helpful, anybody can input their ideas here, and it's shared out with everybody. So we can go through and really see what innovations and experiences people are having and really share the expertise. So that's been really unique and cool to work with 6 different consultants, really smart people, and we're all able to share ideas. So next, I'll actually show you one of our 2D quick checks. So this is a quick check that was done in-house by Brian Varrella and myself, and QC'd a lot by Brian Campbell. So this is 3 bridges out in Otero County. That's in Region 2 at CDOT. And Stanley Consultants brought to our attention that maybe the hydrology is being shared between these 2 bridges. And so you can kind of see through, this is our existing model. You can see right away that hydrology is being shared between these 3 bridges. That flow is actually coming over here. Flow from this first bridge, M21I, is running down to the second bridge, M21J. Flow that's over here is also flowing to M21J. So this was a really unique project that we were able to put 3 bridges into one model, but it really helped us to see the full picture of how the hydrology was impacting these structures. So this software is also unique. You can see we can actually rotate it in 3D. Let me turn off some of these features real quick. So it's really great visually to kind of see what's going on, which is really fun. And I think it's easier for other people to understand when there's a visual component to see what's going on hydraulically. So this is our first bridge. There's a railroad downstream of all 3 of the bridges, which is also modeled. Oops. Here's the second bridge. And our third bridge. So this was a really fun project because we just had endless opportunities to play with. Which is really exciting. We realized that the roadway really wasn't overtopping in any of the 3 bridges, and so we could actually reduce the bridge sizes and even recommend putting in box culverts for these 2 bridges downstream. So I can show you, this is our Google Drive. This is what we've been using to share out all this information. So we're able to upload everything that was needed for this model. And we put together a memo of results and recommendations. This also includes figures. So we were able to turn this into the project manager, and project managers have full autonomy of what to do with this information, if they want to include it in their projects or not, which is really fun. All right, so let me get back to the presentation. I'm going to pass it back to Brian Varrella to talk about return on investment.
All right, well, thank you, Kalli. If you could advance to the next slide. This is the exact same project that Kalli just showed you. You can see the 2 of us, and with help from Brian Campbell doing QA, QC, we completed all tasks for all 3 bridges in 90 hours. That is a total cost of about 5,100 hours, $5,100 of staff time at CDOT. And it saved us about $206,000 total. One bridge was actually, we reduced the initial size of the bridge over what was originally proposed. Did the same thing on 21J, as Kalli said, by converting it from a bridge to a culvert with significant savings. And since this is in a remote area, it was actually a lot easier to suggest a culvert because, for one, it doesn't require as much long-term maintenance. For another, it doesn't require nearly as much riprap to protect it and standard design at CDOT. And finally, because of the soils out here, it significantly reduced the opportunity for scour that was occurring and has occurred in the past in this area. So the total return on investment of that 5,000 was about a $200,000 savings, or a 40-to-1 return on investment. And again, as Kalli noted early on, and as Brian and Sara have both alluded to, this same opportunity can be discovered with all the technology in 2 dimensions. You saw it on a slide previously, as Brian Campbell pointed out. What we're doing is, by using this software, we're reducing the embedded uncertainty in the methodology that we use to design infrastructure in the natural environment. And by reducing that uncertainty, we narrow the gap between the money we think we need and the money we actually use to put things on the ground. So we make smarter decisions, but we don't sacrifice the conservative nature of the methods that we use. And that was really important for our staff bridge department to convey to us as a primary objective, or at least a secondary consideration. We made it a primary objective as part of this experiment. Next slide, please. Here's some other examples. I showed you that 3 years of data. These 4 projects collectively in the top left, that was a project that we worked on largely in-house. We saved $500,000, got a 40-to-1 return on investment with CDOT staff time. And by the way, this is all to completion. The original models only took a day or 2, but the numbers you see here and the returns on investment are returns related to full project delivery. Top right corner, same thing in the Poudre River near Ted's Place on US 287, 50-to-1 return on investment. We had a lot of help from DEA and Ayers Associates on that one. In the bottom right, this is a project I worked on with AECOM and Kim Perry and her team, State 144. This was a roadway protection project. It wasn't about a bridge. This is one of the unique features outside the common hydraulic structure application, where we actually cut the project dollar value in half in 3.5 hours. That was the very first quick check experiment I tried in 2016, and we realized that we were onto something. And then finally, in the bottom left corner, this is another project I worked on with Rigel Rucker and Isaac Allen and the AECOM Champ team, the South Platte River, State Highway 55 near Crook. Again, we cut the project total cost almost in half, but we got about 1,000-to-1 return on investment. And I can't make these numbers up. To be honest, as we've taken 3.5 years of data from Region 4 hydraulics between 2016 and the middle of 2019, we found that that total $14 million savings that I showed you before will result in us likely with creating these 2D quick checks and a new statewide process to go with it. An annual savings to the taxpayers in Colorado of about $20 million per year once it's fully realized. Now, this is a big plane to get off the ground. I'm not saying we can reach full cruising altitude in the first year or even the first 2 years, but I'm pretty confident that by doing this experiment with all of our partners, we're likely in the next 3 or 4 years going to have a full process statewide that saves the taxpayers, including everybody watching here, because I think all of you drive cars, about $20 million per year. So we're stretching that dollar, and that's money that goes right back into projects so we can get more work done with fewer dollars. Next slide, please. And I think, Sara, we're back to you. Thank you.
All right, thanks again, Brian. So part of this research initiative is to support the implementation of the 2D quick checks into CDOT project processes. So this is being done with the overarching goal to provide meaningful support to bolster the project team's decision-making efforts early, and that's a key term, early in the project process. So part of this is providing a training curriculum, and it's being developed, and like the slide said, its mission is to provide levels of support defined within the 3 tiers that I'll talk about below. And so tier 1 is an in-house effort by CDOT where all work is performed by region hydraulic engineers, review and analysis. Tier 2 is where CDOT would perform the analysis in-house, but by other region subject matter experts, and then reviewed by the region engineer. Tier 3 is a blended team, and it probably best represents kind of how we're working now a little bit. And it's an option where the analysis would be performed by a private sector partner, reviewed by a CDOT subject matter expert, and they would work together throughout the analysis and review. And like I mentioned earlier, this is a tiered system, and the training curriculum is to provide support for region engineers and projects teams in performing 2D quick checks. And also, I'll mention that new state funding is expected to help support this effort. And with that, I'll turn it over to Brian Campbell once again to go more in depth on the training component. Brian?
Yeah, perfect. Thanks. If you want to do next slide. So what with all the information that's being presented, to echo what Brian Valero was saying is we're on to something, right? We realize that there's some significant potential here. And coming out of the 2D quick check experiment, I guess we can call it that, we're identifying where some of our shortcomings are, as well as where some of our strengths are. And we've identified, we don't need to reinvent the wheel here. That there's trainings out there. FHWA does a great job of introducing folks who've never touched 2D modeling to the software, but we want to build on that. And one of the best ways to do that is to initiate another curriculum that is specific to the 2D quick check model, to build the confidence of our staff in-house, as well as our partners, that we're not wary of this new technology. We're not wary of the software, and we feel good about the results that are coming out of it. So we begin developing this training course that we plan to launch in about October of this year. And at this time, we're launching it to our internal hydraulic engineers to go through and build that confidence that I was talking about. But we have been given approval that once we brush it up and we're confident with it, that we can now share it with our other agencies and other private partners that are interested. Like I said, it's not reinventing the wheel, but we're going to emphasize more on this quick check procedure. How do you download the data? How do you pull together something quick? And with the intent of coming back into it with the final design later, if needed. The course right now is a 12-hour course. We talk about building the quick check, but we also go through FHWA's and CDOT's own internal reviewer checklist sheet. All of this stuff is available to you folks on the line. And the idea is to walk through those pieces to make sure that everyone's on the same page and they understand what the importance of those pieces are, so that if we're in the tier 1, tier 2, or tier 3 that Sara was showing on the previous slide, everyone's in the same ballpark and we can move forward with confidence, knowing that we are trusting the results and realize the potential of that process. So it's that's what we're doing.
Thanks, Brian. So really, in conclusion, we really hope to improve the safety on Colorado transportation corridors, improve processes to inform statewide planning efforts, enhance infrastructure performance, optimize resources, and expand region hydraulic engineer capabilities for project delivery. And I want to show you guys one more thing. We are putting together these one-page project success sheets. So I just want to highlight these two, where we share out project successes and lessons learned. And these were put together from Brian back in 2018, and we're trying to continue that now in these 2D quick checks. So we have a couple different ones, and I think these are shared out in the resource link that Brian posted in the chat. So everyone has access to these and can read through them.
And I'll post it again right now, Kalli, just so folks can get to it right away.
Perfect, thank you. Great, and that wraps up our presentation. We definitely would love to hear any questions that you have. And thank you so much again for having us today and letting us share this out to you all.
Thanks again to CDOT and its partners for sharing this information. I think it's been a great presentation and exciting to see what continues to come out of this process in the future. Like Kalli said, if anybody has any questions, we have some time now, so you can go ahead and submit them via the chat. We will be providing continuing education credits for this Lunch and Learn, so you'll get a certificate for that here shortly in your email. And this presentation is being recorded, and we'll put this on the CASFM YouTube channel so you can share it with your coworkers who weren't able to attend today. With that, I guess we'll ask any questions.
Tyler, I want to address a few of the questions that were in the chat previously, especially for folks who jumped in a little later.
That sounds
There was a
great.
question about the 1D model, and Kalli, if you can go back to the slides that showed the work that Hannah Crail prepared back in 2016, maybe just slide number 3 would be perfect. What we found with this bridge, this is one that we partnered with AECOM on, and it was our friends at AECOM in Salt Lake that ended up working with us on this. You can see that there's a lot of flow in the overbank coming to that bridge from the west, from the left. And you actually get a collision of flow at the bridge where the main channel runs from south to north, but 40% of the flow is actually in the overbank and has to make that hard turn. So what we discovered is that that shift of momentum actually kicked a significant amount of discharge out of the right overbank, about 30% of it, and sent it off the screen to the right into an intersection that we were trying to protect. So the 1D model, when we place cross sections the way you typically do per the hydraulic reference manual from HEC, it assumed that all that flow actually made it through the bridge opening. The challenge is in that 1D format, it wasn't accounting for this momentum flux where the left overbank bumped water out of the channel into the right overbank, and that momentum transfer wasn't captured. So the 1D model was actually giving us an erroneous result. And when we calibrated this 2D model to the actual on-the-ground photographs from 2013, we found it was accurate at the intersection to within about 1/10 of a foot. It was unbelievable, actually. We were pretty excited about it. And I showed this to my RTD. She was my central program manager, my supervisor at the time, Heather Paddock. I said, what do you think of this? She's like, I don't know why we're not doing this everywhere. I said, well, that's what Staff Bridge just told me. And she's like, well, you had better put together a system here to help us find these savings and these opportunities. And that's where the idea was hatched. So the limits of a 1D model were fully mitigated using a 2D. And then the folks at AECOM in Salt Lake City said, yep, let's use that information, redo our 1D model in a cross-section configuration, and we were off and running. And that model has already gone through its final Lomer stage. Other questions that have already come up. I know that there's been a lot of talk about 1D and 2D. I'm not going to say from a CDOT standpoint that we'll ever get away from both technologies in the near future. I think in a distant horizon, we'll probably see, especially with the advent of RAS 6.0 and other tools as they're evolving, we'll see that there is a mix. But right now, we're finding at CDOT the majority of our regulatory challenges are usually managed with a 1D model, but our detailed hydraulic information is informed by a 2D model. And then I think that covers most of the questions. Yes, we will make all this stuff available to you all. Tyler noted that the YouTube channel for CASFM will broadcast this. He's already sent a link. And then I sent a link to the Google Drive folder and all the materials within that Brian Campbell and Sara and Kalli have been populating. So all that stuff is ready to go. And then I'll stop talking before we start addressing the new questions and turn it back to Brian, Sara, and Kalli if there are other things that you wanted to add.
I was going to make a comment on James' question, if that's right. James asking if there's instances that resulted in a larger cost. In Region 5, I have an example for you. It wasn't the project scope changed. So this isn't an actually implemented result, but it is an example nonetheless. We did a model of a scour critical structure that was in the northwest of the southwest region. And what we found was the pier scour and the skew of the channel was enough of a concern that when you weighted the benefit to cost ratio of doing like a HEC 23 riprap pier protection versus doing a deep foundation, right? Modifying the structure to have a deep foundation to handle the scour. Although the deep foundation was more expensive, it was better in the long run. So again, that project changed scope, so that's not in the field. But when we did the analysis, the recommendation was to go with the more expensive solution in that instance.
Actually, Brian, I've got another example from Region 4. This was from 2018. I was working with Luke Keene in his residency, and we were partnering with RS&H. And we put together a 2D hydraulic analysis that was started by Steve Griffin before he left in 2015, and he's back at CDOT now. He's the hydraulics unit lead for Region 4. The long story short, what we realized is that the crossing of the South Platte River in Milliken and Weld County was basically a long causeway that was overtopped in lower recurrence interval events. And so I looked at the 2D model and the initial results, and I went to my resident engineer and I said, Lou, I think if we raise the roadway just a little bit, we can eliminate overtopping and still cause less than half a foot of rise in an unnumbered A zone. He said, we can actually do that? I said, yeah. So we went to the RTD, Johnny Olson at the time, and said, if we can do a 6-inch overlay in here for $500,000 on a $12 million project, we can have a safe corridor between US Highway 85 and Interstate 25 to move emergency service personnel with our new bridge. I said, the new bridge is out of the water, but the approach to the south is not. And Johnny said, so you tell me if we're doing a 6-inch overlay for another $500,000, we can have an emergency access corridor? I said, yeah, that's all it takes. He's like, done. So in that case, we did actually find a safety enhancement, significant safety enhancement that benefited all communities, all parties around the US 85 and the I-25 corridor in Northern Colorado, where in 2013, there was no access. Those two corridors are the two primary economic corridors for Northern Colorado. And they were 100% cut off from one another for a period of 12 to 36 hours. And that created chaos for our emergency services personnel and for the folks who needed emergency service assistance during that time. So we actually did find a project increase with the 2D analysis, but it was a major safety win for the remainder of our traveling public. And CDOT actually received an award for the governor for innovation for that idea. So sometimes more money doesn't necessarily mean bad things. Sometimes a small investment of public dollars results in significant return on investment of tangible and intangible benefits to the traveling public. Lisa had a question about LiDAR. Yeah, Lisa, LiDAR is interesting. I know talking with our friends at AECOM, Kim Peary suggested that they tried a model in 2 dimensions with LiDAR, and then after running that, they acquired more information in the channel to get channel bathymetry. And the delta between the 2D model with channel bathymetry and the 2D model with just LiDAR was just a couple of tenths of a foot. And we were looking at depths of over 12 feet. So it was a drop in the bucket in that case. It's not the case in most of our canyon areas. The delta between with LiDAR and bathymetry versus without bathymetry can sometimes be feet. So it's really location dependent. I always say, use all the survey you have at your fingertips all the time. Follow the standard protocols. LiDAR will never eliminate the need for TMOS survey at CDOT, never. However, when you're doing a quick check, you're doing something back of the envelope, you're looking for a trend. And as Brian Campbell's told me, most of the time, within 3 or 4 hours, you've got your finger on the pulse of a solution. And it still requires more work afterwards. So can you do a 2D quick check in half a day or a day? Absolutely. Does that mean the work is complete? Absolutely not. So to answer your question about LiDAR, I still recommend everybody get as much survey information as they can using standard survey techniques and protocols that we're all using in design and construction project delivery. But for the purposes of a 2D quick check, in most places, LiDAR is adequate. Just remember, your water surfaces will probably be higher than actual only because you're not picking up on the conveyance associated with channel bathymetry. Other thoughts from the group or questions from our audience?
Looks like that might be all the questions we have today.
Well, thank you so much again to everyone. We're really excited about this and we're excited to share it with everyone. So we appreciate everyone tuning in and for all the questions.
Thanks again to CDOT and their partners for putting this on. We'll go ahead and get those materials out to everyone, and pay attention to your email and the CASFM calendar for future upcoming lunch and learns. All right, thank you.
Thank you, everyone.
Thanks, Kalli.